Hello and welcome back to the lab. Today on the bench, we have a pile of chemicals and PPE. Let's get into this. So the reason for this video is YouTube showed me I needed to make it. A video popped up on my feed called Rosin is Not Your Friend by Auntie Tay, who did the channel. And it turns out she had a pretty bad experience with doing some of the resin artwork and epoxy artwork that has been going around for a little while. I'll leave a link to that video in the description, as well as two other videos, one from Maker's Muse and one from Marco Reps, also on similar topics. Maker's Muse goes kind of deeper into similar topics when it comes to laser cutters. I'll touch briefly on that here. And Marco Reps goes into some more topics on lasers and PPE, especially some of the, with the proliferation of devices that I'm seeing, that led me, those three videos led me to make this video, as I have a lab and I do makers type activities. I'm seeing a few questions from people about some of this, and I also know I'm getting some younger viewers to the channel who are just getting started, who may not have the experience necessary to work with some of this stuff safely. So this is going to be an obligatory lab safety video that I think needs to be added to my channel, just to kind of help everybody get started. Professionally, I am not a medical professional. None of this should be considered legal or medical advice. That goes without saying. However, I do have some extensive background working in industry, everything from heavy to light industry, and I've been around PPE and associated hazards and chemicals for quite some time in my professional life. And some of the things I've had to do in the last couple of years, I even needed to get dangerous goods certified for shipping hazardous materials and things like that. So I had to take a DOT course and do a few other things on how to move some of this stuff in large quantities. You do not need to be dangerous goods certified to ship, say, a bottle of rosin flux. You do when you get into, I need to ship a pallet or several pallets of rosin flux. What I was shipping specifically was actually isopropyl alcohol, and what was really funny is they would send a 5-gallon bucket of isopropyl alcohol to my door for me to use in a lab. And when somebody asked me to source a pallet for them for various reasons, I was told they wouldn't even ship it until I was dangerous goods certified, so had to do that real quick. My intent of this video is to be an overview of lab safety. This will by no means be a exhaustive list. And I cannot say that strongly enough. This is by no means an exhaustive list of the safety protocols for a lab. I've been doing this stuff for so long. Some of this stuff is even subconsciously done, especially some of the high voltage protections, things like that I do in the lab when I'm working with other things. A lot of this stuff is on automatic because I've done it for so long. The problem with that is you make mistakes. This is one we'll talk about later in the video. This was when I screwed up. Fortunately, nothing happened. I breathed a little bit of acetone for a while. Wasn't on purpose, and was enough to where I couldn't even smell it or feel the effects. However, this is a problem. I will also get into why these suck. These bottles, they're nicely labeled. They're terrible. And I had one of these empty itself onto the desk. Wasn't either of these two, but I had another bottle with WD-40 in it, and it emptied itself out. Nobody touching it. It sat on the desk. I literally watched the level drop. It wasn't evaporating. When I looked at the table, it was covered in WD-40. We'll get into why that happened too. So this is my target for this video is kind of general overview of Maker Safety 101. So this is going to be specific in a lab context like mine. So there'll be some voltage stuff, some some chemical stuff, some environmental stuff, and other particulate that will somebody who's using general maker tools might run into. But I also want to give some information on where to find information if you end up hitting outside. So we will get into some MSDS. We'll talk about what these pages are here in a minute. And we'll also talk about how crazy this gets and things like that. So if that is of interest to you, stick around and we'll get through it. I know it's not the most glamorous topic running around, but it is also necessary to discuss every once in a while, and I haven't run across a good overview video yet, so that is the purpose of this one. I tried to find some examples of where I've had some voltage mishaps or power mishaps, and I could not find any. That is not to say they do not happen. I am human and make mistakes. However, some of the things specifically that I wanted to show, I don't have anymore, so, or have healed. You can see one of my mistakes. I will also, I'll have to keep a note of how many links I need to put in the description because I'm about to mention another video. I believe it was on my Type 106 when I was doing the square wave generator. I got blasted in the thumb where I took about 300 volts through the finger. Came in this side, went out this side. Gave me a nice voltage burn on the edge of the cap. One thing to note is if you do end up cracking open any of the more vintage pieces of equipment and they have those plastic caps over top of the capacitors, there is positive and negative supplies. If it is a negative supply, the outer casement of the can is high at voltage levels. So it will be a shocking experience if you touch that when it's on. I got bit. I know better. My finger slipped in between the can and the ground rail, so my finger shorted the, I think it was a negative, either 190 or 300 volt supply to ground, and I'm lucky it went this way through the finger and not this way up my arm. However, I did feel that all the way up here. Even though the voltage went through here on my finger, muscles contracted all the way up here. So some of this stuff is no joke. If you work on industrial power, electric, things like that, and you're not careful, they can actually lock you onto the conductor, which is how a lot of guys get toasted. They'll touch the conductor like this. They'll grab it like this. What happens is the AC locks your arm up, and it literally causes everything to just tense up, and you can't let go. So you're getting blasted by this thing, and you can't get away from it. So AC, especially industrial AC, is very dangerous. If you're ever working in an electric panel, please, please, please have somebody who knows what they're doing or be comfortable doing that type of work, especially if you're working on it hot. I know a couple of buddies of mine are certified electricians, and I call them for assistance sometimes. I'll do a lot of the stuff myself. I did a lot of the AC wiring in here. I did all the AC wiring on the table. When it comes to opening the panel and landing things in the panel, I call them. One of the reasons for that is because even if you flip the main breaker in that service panel, there is still voltage in that panel that you cannot turn off. It's on the feed lines coming in on the top side of the breaker. There's lugs that are in there. Those are still hot with power, even if the main breaker's turned off. In at least this is true for North America, which is where I'm at. The only way to truly kill power to that breaker panel, if there's no disconnect switch, is to pull the meter base on the side of the structure. You have to get the power company to do that here. So if the meter base is plugged in, meter base being the actual AC meter, if the meter's plugged in, there's no way to 100% isolate power to the box. Now the problem is with that, in my location, I have two panels that are 150 amps each. We have a 300 amp service. There's a 500 amp service to the meter. So if the meter's plugged in and I hit one of those lines that's on the wrong side of the breaker, I have an unrestricted 500 amp pipe from the power company through me to ground. That's a bad day. So always, 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 especially with industrial power. And I would hazard to say that North America's power, being 110, is actually more dangerous than, say, a 240 or one of the other voltages that you might find in the world. Because I've heard a lot of people say, it's only 110. It still bites. It hurts. Perfect example of that is what happened to one of these tools. This is a multi-tool that I carry as part of my everyday. I had one where the chunks of the plier right here had been blown off because I was putting a fuse into a 110 circuit and the power was turned off. I had turned the power off. I did not use a lockout at that point. Hindsight being I should have. But I was working with another gentleman, and he didn't know that I had my hands I was plugging in the fuse, and he flipped the power back on, and I had an arc welding spot on my pliers permanently where it blew material off and liquefied the metal and re-solidified just from a fuse. Now that was from a 15 amp circuit, same thing that's available right here. Did that. So that wasn't even the industrial. That wasn't even the 500 amp service that I have available at the breaker panel. That's what comes out of a 15 amp circuit. Now the bench is all 20 amp stuff and things like that. But I have a significant. I have significant experience working with 110. 240 gets me a little skittish. American 240 gets me a little skittish. And I really don't like working on anything in the 480 range, things like that. I'm not an industrial electrician. I'm a technician. That is a different skill set, one that I have a small amount of knowledge on, how to stay safe on my end of things. But as soon as I get to the end of my end of things and it needs to go further back towards the power plant, I call somebody and say, hey, here's what it's doing. I need some help. So that's one thing that's the first thing in lab safety is know when to call for help. If you're uncomfortable doing anything, especially if you're working on something new or you're doing something, find somebody who's knowledgeable, find somebody who's done it a few times. Be very careful on some of this stuff because this stuff is hiding in plain sight, and some of this gear can be fatal just in its normal operation, let alone if you open the covers. So, perfect example is the 577 over on the bench. For those that don't know, this is Tech's little brother curve tracer to the 576. This guy will source 1600 volts at 100 watts, and it has no problem doing that all day long. I don't want that to go through my fingers. Which goes into voltages and hazards. I think my fluke meter says anything over 50 volts is considered a hazardous voltage. I also take into account the current that's behind it. I don't like messing around with car batteries too much. I'm going to fill this in with a couple of industrial stories to kind of drive points home. I won't be too graphic with the stories. Some of this stuff, people did get injured. And then now, towards the end, I'll share 2 industrial stories where I got surprised, didn't even think there was a hazard, and was told that I could die. Just flat out, the guys that I was with, they're just like, no, if you screw this up, you're dead. So we'll get into that towards the end. This particular story was a automotive technician. He had a ring. You'll also notice I wear no rings. You'll never see me with a watch. I actually can't stand stuff being on my wrists at this point. No rings, no nothing, no jewelry, nothing. A lot of that comes from when I was working on heavy machinery. We weren't allowed to wear necklaces. We weren't even allowed to wear a name tag. The guys in the shop that had the name tag, that had their names on their shirts, They were stitched on and embroidered on. We weren't even allowed to wear a name tag because they were afraid we were going to get sucked into something. So they did take safety quite seriously, and rightfully so. We all went home at the end of the day, and we all still have all 10 fingers, toes, and nobody has chronic problems. This particular gentleman was working on a car, so a 12-volt supply. The problem with a car is you got 6 to 1200 cranking amps out of the battery, so the battery's capable about dumping 600 to 1200 amps. That's a huge amount of power. It's only 12 volts. You're not going to get shocked or anything like that. But what happened to this particular gentleman is he was wearing a wedding ring on his finger, and his wedding he had a wrench in his hand, and with the wrench and the battery terminal, somehow what happened was his wedding ring got spot welded to the battery terminal. For those that are a little squeamish, this one's going to get a little graphic, so you may want to skip ahead a little bit. Because the ring spot welded to the battery terminal, it had 800 amps flowing through it. The ring got incredibly hot, and it actually burned his finger off. He lost his finger in that incident. So, so 12 volts with current can be dangerous. So even car batteries, like, I don't mess with car batteries because of the current potential that's there. I respect those just as the same way I respect a high voltage supply and a scope. I don't give it a chance, and I understand it's the boss, and it lets me manipulate it safely and go home at the end of the day. So the other thing is, don't fear this stuff. If you fear it, mistakes will be made. Respect it, but don't fear it, I guess is what I'm trying to say. So that's a couple of those. I will also leave a link to the high voltage video that I did, which was a primer on using a high voltage probe and taking high voltage measurements safely and correctly. So we will do that as well. Let's talk chemicals. There's a lot of different chemicals in the lab, and this is probably for a maker other than machinery. In my case, voltage. This is probably the biggest hazard people are going to come in contact with or be exposed to. In a lab, we use lots of different chemicals. So we've got this. We've got this. Yes, distilled water is a chemical. It's distilled water. Of everything that's going to be on this is not going to hurt you to drink it, as you can see from the diamond. However, it tastes like crap. We have this stuff, which this stuff's kind of crazy. I actually don't like this stuff anymore. Here's another lab chemical for electronics, and we got some more of that. So, what are the hazards here? Well, this is distilled water, so this is pretty mundane. The isopropyl alcohol is flammable. The flux is flammable. This electronics lube is flammable. This is a freeze hazard. So if you use this incorrectly, it can actually freeze skin, do all kinds of horrible things, give you frostbite. Even something over the counter is a chemical in a lab. So where do you go to find out what the hazards are and how these chemicals should be handled appropriately, and what PPE do you need when handling these chemicals, or any chemical? Well, every chemical, at least in the US where I'm at, comes with or can be found a material safety data sheet, MSDS. Now, if you are in an industrial location doing some of this work professionally, there should be a book somewhere on site that has every chemical in the building, this sheet printed out and in the book. Every place I worked, every place I've been professionally, no matter what it was, had an MSDS. So chemical, right? MSDS sheet for water. These guys, so even distilled water has an MSDS sheet to it. Now, some of this stuff, every MSDS sheet has the same sections to it. It goes through the same hazards to it. This happens to be the MSDS sheet for the distilled water. This happens to be the MSDS sheet for the isopropyl alcohol. The MSDS sheet for the distilled water is 6 pages. 6 pages for water. The MSDS sheet for the isopropyl... Oh, see, now that's flammable because I pushed up. This is why these bottles suck. The MSDS sheet for the isopropyl alcohol is 17 pages. 17 pages for rubbing alcohol. This is the same thing you buy at the grocery store. It's a little more pure, but you can buy 99% rubbing alcohol at the grocery store. Same stuff. 17 pages. So, reading one of these, especially if it's a chemical that you haven't used before, is always a great idea due to the fact that it will tell you hazards, how to clean it up, what PPE you should be wearing. In section 2, which is hazard identifications, you have the toxicity, and like the isopropyl alcohol is an eye irritant. It's also very flammable. And then the category is, at least for the North American MSDS, it's out of 5. So 1 is the highest severity, 5 is the lowest severity. So this has actually, I don't even think this has a flammability. Severity. See, now, but some of this stuff I don't understand either. Because after skin contact with distilled water, wash affected area with soap and water. Water. So some of this stuff is just to keep the sheets the same. So, however, we have a highly flammable liquid, and then we also have an eye irritant, and then we do have actually organ toxicity, which means it's gonna hit some internal organs, which you will find out on subsequent pages. It'll also do precautions, things like that, which is avoid breathing fumes and vapors. We'll get into that a little bit later. These are supposed to be in a fire cabinet, ground bonded for sparks. Actually, there are some specific boots that you're in a wild environment when you got to have nails through your boots to make sure you're grounded for explosive environments and spark dissipation. No kids, wear protective gloves, protective clothing, and eye protection. We'll get into that a little bit here a little bit later. I'm sorry, this is not isopropyl alcohol. I misspoke. This is not isopropyl alcohol. Let me go get that one. This is the MSDS for the rosin flux. I grabbed the wrong sheet. Okay, here is the correct MSDS for isopropyl alcohol. Still 14 pages. So mistakes are easy to make, especially when looking at some of this stuff. Product name, and in the MG chemicals, the number is very important. So 824. So 824 is their isopropyl alcohol number. 835 is the flux number. Now down here, under the product identifiers, we have isopropyl alcohol electronics cleaner, and then we have rosin flux 835. So that tells you which chemical you're looking at the data sheet for. Now, let's go through the isopropyl alcohol, because it's probably one of the more common chemicals. All right, this will give you an idea as to how much information's in here. Here's the packet, right? That's 3 MSDSs. There's a lot of information. This is 3 chemicals. You can imagine in an industrial setting, books, plural. You can get a ton of these. Now it has some great information in it, especially when it comes to if there's ever an accident, firefighting, cleanup. Those are really good things to know. There's a specific chemical, the liquid tin, that you use on circuit boards. It's extremely toxic to fish. So this will even tell you, if you look up the MSDS to that one, it'll say highly toxic to aquatic life or something like that. It doesn't take much to just wipe fish out. So that's why disposing of some of this stuff is also properly is also very important. So we have a we are on the 824. This is the isopropyl alcohol. Causes serious eye irritation and may cause drowsiness or dizziness. Is some of the health hazards. Eye irritation is pretty important, and we'll get into that later. Pouring stuff, it loves to find eyeballs. I don't know why, but splashes, that's probably the one thing that I will put safety glasses on when I'm pouring out of this bottle into that bottle, because invariably it's going to splash, and it's like immediate right to the eyeball. It's crazy how liquids like to find eyes. But we also have a highly flammable liquid and vapor. Actually, we're still pretty close. So the rosin flux is about as toxic as the isopropyl, because we have flammability of 2, eye irritation of 2, and organ toxicity of 3. Again, very similar, actually, data sheets. Actually, less precautionary statements on the isopropyl alcohol than the rosin flux. Wash hands after handling, gloves, eye protection, face protection. Under the response section, you can have precautionary statements, which will tell you things like firefighting, dry chemical, carbon dioxide, chemical foam, water spray, or water spray to extinguish. You know you're kind of working in a wild environment when you start seeing Class D fire extinguishers. Also, one that a lot of people aren't familiar with is Class K fire extinguishers. Class D is more exciting than Class K, because Class K is for a kitchen fire, essentially like a grease fryer and a deep fryer. Class D, however, is flammable metals, so magnesium, thermite, although thermite's really hard to put out because it's self-oxidizing. So you know it's kind of getting wild when you walk in and you see a Class D fire extinguisher on the wall. Some storage. Storage is also very important. Check local ordinances and laws on storage. Where I'm at in the U.S., I am allowed a 5-gallon limit of fuels. So I can have as many containers as I want. However, I am limited to 5.5 gallons per container before I run into special legal requirements for storage. That was one of the reasons why I needed that hazardous goods shipping, because I was shipping a pallet of this stuff. And they're like, yeah, you're getting into quantities where we want you to know what to do with it, so go get certified. Under Section 4 for first aid, you end up with response conditions and responses for on skin, in eyes, if inhaled or swallowed. So depending on what happens, obviously. Now, we do have an inhalation hazard here in my lab if I use too much, because ventilation is an ongoing problem in the lab that I'm working on addressing. I'm getting some powered vents. It's not awful, and I have some monitoring, which I'll pull up here in a little bit, but it can cause some problems. So proper ventilation is key for most of this stuff. A lot of this stuff can be minimized with just ventilation, but definitely check the MSDSs for the immediate response. So specific hazards in the firefighting, vapors are heavier than air, so they can accumulate down in low areas and cause a flash point. This is true for alcohol and also fuels like gas and a few other things. And then also a self-contained breathing apparatus when firefighting, so don't run into an alcohol fire without portable air. Under Section 6 is accidental release. Essentially, if it's spilled, some of the common sense cautions: if you've spilled isopropyl alcohol, don't light it on fire. Simple stuff like that, but this is how to clean it up. Now, bear in mind, I'm using isopropyl alcohol as a example chemical. If you get into some of the more lab level chemicals, for the sake of argument, dimethylmercury, this stuff gets a lot more important real fast, because isopropyl alcohol, everybody uses it in their everyday life. Dimethylmercury, 2 drops will kill you. We have some chemical stuff, and then some of these are good to know if you're going to be using a chemical a lot, because some of the exposures and things like that with chemicals is there's difference between short-term and long-term exposure. Short-term exposure is you're using it and then it's put away. Long-term exposure, and these are all formally defined if you want to go that far down the rabbit hole. OSHA and a few other governing bodies, at least where I am at, have defined what short-term exposure is and what long-term exposure is. So if it's a chemical you use every once in a while, short-term exposure. If it's a chemical you're using every day, hours and hours and hours a day, repeatedly, say for instance, rosin flux if you drive a soldering iron all day, long-term exposure. And you'll also notice that the long-term exposure limits are lower than the short-term exposure limits. This is still for the isopropyl alcohol, so we're at 400 parts per million. And then we also have some Canada information here too. Actually, it looks like US OSHA hasn't established short-term exposure limits. But then long-term exposure limits 400 parts per million. So not used very often, used very often. And regardless of what the chemical is, traditionally, the short-term exposure limits will be slightly higher than the long-term exposure limits. This will also depend on chemical. Check the data sheet. I'll have to say that a lot. Check the data sheet. All the information's in here. And if you haven't read one, it's a good idea to read one, especially because you'll find out a few things like the ferric chloride that I use to etch circuit boards. It doesn't like to be heated past 50 C. At 50 C, it cracks and breaks down and chemically starts to deteriorate. It's in the data sheet. Section 9 is a physical and chemical properties. Essentially gives you a whole bunch of valuable information. This is, again, still the isopropyl alcohol. Some of the things of importance are some of the vapor pressures, evaporation rate, whether it's flammable or not, always. Auto ignition temperature is also pretty important, because that's essentially when it's going to, burst into flames spontaneously. The other thing is the odor threshold. This is essentially like when a person can start to smell the chemical. 440.44 ppm. I think that's parts per billion. 440 parts per billion. Or is that 4.4 parts per billion? I can never remember. I think it's 4.4. So 4.4 parts per billion of the chemical to atmosphere, and you can start to smell it. So it doesn't take much to actually start smelling some of this stuff. Essentially, Section 10 is stability and reactivity. This is what's kind of important for the ferric chloride. You get decomposition, and it says it decomposes, chemically decomposes at above 50 C. And then incompatibilities are also very important. This is, don't mix this with stuff. There are certain things that under no circumstances should ever be mixed. A perfect example of that is any ammonia-based cleaner and any bleach. Both of those are found at home. Do not mix those. Bad things happen. And then toxicological information. This is some of the testing that was done. We have rat and rabbit testing that was done. And then we have inhalation, dermal testing, and oral testing. It is what it is. I did not test it. Toxicological effects are always good to know, especially when it comes to lungs, eyes, and skin. We'll get into that here in a little bit. Those are the important ones, lungs, eyes, and skin, at least for most lab chemicals. Obviously, a chemical isn't going to damage your hearing unless it gets in your ear. However, don't sniff the stuff either, because chemicals can burn out your nose pretty easy, and your nose is pretty fragile too. Typically listed toxicological effects, God, I can't talk, are skin, eye, sensitization, which is an allergic reaction. So a material that causes sensitization would be beryllium. So if you're cracking apart microwaves, there'll be a pink metal in there. Some of this test equipment actually has beryllium in it. That's good to know, because you can get, I believe the condition's called berylicosis, but essentially it's a pretty severe allergy to beryllium metal. So once you're sensitized, you end up having an allergy to that contaminant, and as an allergy sufferer, that's no fun. I've actually got some pretty crazy medical allergies that I was tested for. Like I'm actually allergic to cobalt the metal, which is one of the more rare ones. I have no idea where I picked that up. I'm also allergic to nickel, which is pretty common. I have skin reactions to nickel, things like that. So sensitization can happen. Essentially, cancer risks, mutagenicity, which is the, I believe this is DNA damage, or it can change genetic problems. I don't work with a lot of stuff that's mutagenic, so that one I haven't done too much with. Reproductive toxicity, much more of a consideration for actually my mother, who is a chemist. When you're in the lab, things happen. She was in a not repair lab, but chemical lab, so a lot of caution there. Tetragency as well, and then some single exposure, and then aspiration hazards. So all of this is good information. Section 12 is ecological information. This is disposal, what you can and can't do, how you dispose the chemical. Also, check local ordinances. Some of the stuff can go down the drain. Some of the stuff cannot go down the drain. Some of the stuff should never be put down the drain. And some of the stuff you get in trouble if you put it down the drain. So definitely check with the ecological information. Some of the other problems you run into is, let's say you have a chemical of some sort that is on the more terrible side, and you dump it down the sink in the lab. Well, that's got to go to the water treatment plant, which the water is going to get more chemicals in there, and it's an unexpected input. So they could have crazy reactions at the water treatment plant that they're not even expecting, because there's chemicals in the water that shouldn't be there. So definitely get this stuff disposed of properly. If you need to ask questions, ask as many questions as you need. I've never gotten in trouble for asking questions, but definitely find out what you need to do. Paint's another one. I'm actually getting rid of a bunch of paint here soon. This is the dangerous goods stuff that I mentioned earlier. This is tagging and transport. So this is the placarding that you see on vehicles and things like that, flammability ratings. And this is split for if you ground transport or air transport. Some of the stuff, like these are just power bricks, lithium batteries. Because they're lithium batteries over a certain size, are not allowed on airplanes. Don't take the big ones. TSA will not let you, well, TSA for me, but the governing bodies will not let them on airplanes, and you will have to throw them out, and they're very expensive. So know what the power limits are of batteries that you can take on an airplane, and there is a power limit. This can fly. This cannot fly. Too big. So, won't go through that again, but all of these are available free of charge from the manufacturer of the chemical. All you have to do is search the chemical's name, and you will come up with the MSDS. That's an overview of an MSDS. If you have any questions, I will leave the links to these 3 in the description below, and you can check them out yourself and read through it and kind of get an idea of what's in there. However, as we compare the isopropyl alcohol to the rosin flux, we have a lot more precautionary statements on the rosin flux than we did on the alcohol, just because it's different chemical, different handling. So one of the ones is, if inhaled, remove person to fresh air, keep comfortable, call poison control or doctor if you feel unwell. So that gets into some other of the PPE we're going to talk about a little bit later in the video. Essentially fume extraction here in the lab. So, okay, so we've discussed some of the hazards and identifying some information about chemicals that are in the lab and things like that. I said I'd talk about this. How did I screw this up? Well, this had acetone in it. These are Menda bottles. I actually really like them, and I use them quite often in the lab. Here's one for isopropyl. If you flip the lids up on these, there's a pump where if you push this pump down, if it's full enough, it is, you'll get a little bit of what's in the bottle up on top. Now, the nice thing about this is what's on top of the bottle does not flow back into the reservoir at the bottom. There's a check valve in there. So you can use Q-tips on this. You can dip them in there. You can use this to clean rosin off the board, get a little bit more alcohol, clean rosin off the board, and you won't contaminate what's down here. It'll only contaminate what's up there. And then every once in a while, you just wipe this off with a paper towel. So Menda bottles, at least that's what I've found them under the trade name, are nice. I also liked this particular one because it was appropriately labeled for the isopropyl and things like that. So container-wise, this is a glass bottle with a pump-style lid. And I went to use, I had this full of acetone, and I went to use it, and there was none in it. It's supposed to have a gasket seal right here. You can kind of see the gasket seal. Well, that gasket seal didn't hold the acetone back, so when I found it, that was empty. So, which means the acetone only went one place, and that was into the air of the lab because it evaporated out of the bottle because it didn't come through the glass. So, acetone really likes to evaporate, low vapor pressure, referred to the MSDS. So that gets into proper storage. That also gets into why I hate these bottles and why I hate these bottles. There you go. So we got some alcohol that came out just because I dropped the bottle on the desk. These bottles also leak with temperature fluctuation. So what will happen is if you squeeze a little bit, see, and it dribbled out over there. So the paper towel actually wipe up some of this, wipe up my mat because I haven't cleaned it recently. These bottles with temperature fluctuation, as the room cools down, they pull air in, but as the room heats up, they push product out. So what happened was I had a bottle of WD-40 that was sitting, a bottle just like this of WD-40 that I was slowly watching the level just disappear. It was what it was doing was, as the temperature in the room was fluctuating, it was actually stored in the garage, unconditioned space. It was pushing product out. It was just puking all over the table. Now, fortunately, I had some towels underneath the outlet of the bottle, so it didn't get everywhere, but the table was coated in WD-40, the towels were soaked in WD-40, everything was just covered in WD-40 because the bottle didn't hold it. So I am not a fan of this style bottle much at all. I keep 2 in the lab, but for the distilled water, it's all right because it's water. I mean, this is actually really convenient for doing solder sponges and stuff like that. For the flammable ones and the WD-40, I will probably be getting rid of this bottle. So that's why I don't like those. Also, take a look at storage requirements because you may only be legally allowed to have X amount of a certain product in a structure without needing special storage and things like that. I'm actually, because I'm starting to get more and more of these chemicals, things like that, in the lab, I am looking at a fire cabinet. The cool thing about a fire cabinet is it is to keep the fire out, but what happens is even if you have the doors open, the doors will automatically close if there's a fire. There's a very low metal tab that holds the doors open, and once that melts, the doors will actually swing closed and keep the fire away from the flammable substances. So, especially with buying in bulk and a few other things, I'm thinking about getting some upgrading some storage. Now, what do I buy in bulk and what do I not buy in bulk? I buy fuel in bulk because I have to run some yard tools and things like that. A few other things, so I burn through gas, and so I do buy some fuel in bulk. Keep a little bit of diesel in bulk. I do not buy rosin flux in bulk. Actually, I bought this 1 liter bottle, and I don't even dispense it out of this bottle. I dispense it out of a needle bottle. And this will probably last me a decade. So you do not need a gallon of flux. You do not need a whole bunch of flux. This will last forever. Alcohol, it's cheaper in bulk, and I use a lot of it. So I do buy my isopropyl in a 20-liter pail. This stuff, since I got filtered air in the lab anymore, I'm discontinuing use of this. I've never really liked it. I never got enough pressure out of the cans anyway, and it was just spraying stuff around. I need to read the MSDS on this one, actually. Obviously I got that at Micro Center, I guess. That's a Micro Center tag. But this is good. One of the things that I really liked about this one is it lubricates and protects, and it's safe on plastics. So that's why I keep that can around. These guys, Max Pro, make a rubber rejuvenator for printers to help with the rollers and the printers and help them grab paper and stuff like that. Do not get that on anything other than the printer. Holy crap, that stuff is caustic. It loves to eat stuff. Great for the rubber, horrible for everything else. Okay, so we talked about a whole bunch of hazards, and we talked about how to get some information on how hazardous something is. Let's talk about how to protect yourself from a hazard. So, really, we have 3 ways of doing that. 1, we could just abstain from using the chemical, not use it at all, don't even open the bottle, but that's not realistic. We have to take into account the things we're going to use. Things need to be used to do the job. So that's where PPE comes in. And we have a couple of options. That's going to sit like that because it's not going to stand. And this is about, other than some gloves. I don't have any gloves with me because I ran out of nitrite. Of course, I want to do a lab safety video and I run out of nitrile gloves. But it is what it is. We can shield or filter. So for lungs and things like that, you can't shield the lungs because then people suffocate and die. So we have to filter. But for the eyes, we can actually shield for splash and things like that. So I know it sounds dumb, but I've even started to do it where even if I'm moving chemicals from container to container, I quick put on a pair of safety glasses. Reason being is I have been splashed in the eye more times than I want to admit from just saying, "Oh, I'll fill it up real quick and it won't be a big deal." And the thing hits just right and right into the eyeball, and then I got to go flush my eyes for a while. Now, I have been incredibly fortunate that what I've been exposed to has not caused permanent and irreversible damage. And I also flush my eyes out very quickly when that happens. But as with everything safety related, an ounce of prevention is worth a pound of cure. So, safety glasses. This gets me into, and a mask. This gets me into something, into a deep topic that I'm going to gloss over very quickly. This is not a end-all be-all lab safety video. This is not a comprehensive video. This is a overview. All safety equipment, all true safety equipment, regardless if it's safety glasses, if it's masks, filters, things like that, they all come with a rating. Now, that rating should be by a governing body that is someone that you ultimately trust. In my area of the woods, that is OSHA and NIOSH. That's who I trust. Now, you're going to see a lot of 3M equipment. This is not a plug for 3M. They did not sponsor this video. However, they are huge in the PPE space in the U.S., and they make some of the most comfortable and best PPE that I have found. And they also have some pretty neat features when it comes to actually using the PPE, getting the job done, and they do the best they can to keep the PPE out of the way so I can do my job and still be safe, because if the PPE is not comfortable, you're not going to wear it, and you're going to take it off as soon as you can, and it's going to be terrible, which is why I don't use these. I bought this pack like 10 years ago, and they've never come out of this pack. So I do not use these. I have them here in a pinch if I have a couple of extra people that I don't have enough PPE for. I don't use these. I do find them to be a little wasteful because of the limited use nature of them. So I get rid of these. What I use instead is one of these. This is actually a half-face respirator. I have this one loaded with a 6001 charcoal cartridge, which is good for organic vapors. But I also have them loaded with the P95, which is the same filter efficiency as an N95. The P just means it's tolerant of oil. So where are those N95s since I threw them? If I was doing like oil spray in the garage, the N95 is not rated to handle the oil spray. This will degrade the filter media and will stop filtering a lot faster than it should and expose me to a hazard. That's where the P95 comes in. The P95 is good for the oil spray. So what this actually looks like is this is just the P95, and as you can tell, it's the same material that's in the N95s. It's just labeled P95. Now, one thing I did notice is it says mask side. So this side goes this way onto the filter. This is a general use filter for me, or for the way I have it set up, because I've done some things with paint sprayers and things like that where I've needed a little bit more than this. This gives me a much better seal. Also, if I have to wear this for hours and hours and hours on end, this is far more comfortable than those N95 masks. I would much prefer to have to wear this for a 12-hour shift than one of those. So the charcoal canister, and this gets into kind of some filter ratings. Check the documentation on all of this stuff. That's outside the scope of this video, but also another topic. If people want me to do a deep dive into filter ratings and things like that, let me know. It is something we can do. This is but I have an anecdote on how choosing the right filter can save money but still give you the protection you need versus burning expensive filters when you don't need to. This combination, I think it's $10 for a pack of 10 of the P95s. Now, the other problem is these plastic pieces that go over top, you'll want 2 cases of these because these have a tendency to crack. That's the only bad part about this is this plastic. If they could do something with this plastic to make it not crack as much, especially when it's cold, this would be a lot more robust setup than it is. But this is still good. So we get charcoal filtration, which is organic vapors, essentially nuisance vapors. This isn't immediately hazardous to life and health. This is the area smells bad. And we also get a dust and particulate filtration from the P95 and a pre-filter, so we don't burn this up with dust. We let the charcoal do its thing. Especially if the area is very dusty, you want a pre-filter because it's a lot cheaper to change these pre-filters than it is to change these. Now, these also have a limited lifespan. Once they've been open for so long, they need to be disposed of and refreshed. So they'll sit on the shelf for a long time as long as you don't tear open the package. As soon as you tear up the package and they start absorbing things just from sitting in the air, they'll start losing effectiveness. Now, if you were in an industrial setting and you were looking to buy one of these, what they do is these are actually fitted. You'll notice this one actually says medium. They come in a small and they also come in a large. I need a medium. What they do is they pop a couple of filters on it and you wear this. They spray some smelly stuff around you. And do you smell it? Yes or no? If you smell it, that means you did not get a good seal here. And so it's not effective for protecting you because it's leaking. If you can't smell it, you got a good seal. This is good to go. It's the right size, and you have a good filter component. Should also be noted, this does not work. This is the filter, although they are replaceable, which is one of the reasons why I like this one, because I don't have to replace the frame. I can just replace the cartridges, which makes them much cheaper to run in the long run than keep doing the N95s. They just twist on and seal. The way you check the seal is you hold here, make sure you can pull a vacuum. If you can pull a vacuum, you've got good seal on the cartridges, and it's not leaking anywhere, which is the important part. This is their quick latch system, so if I ever need to talk to anybody, I can pop this up and the mask will fall down, and then I can push this in and it'll go back tight to and seal back up. The reason they came up with that is talking to someone through one of these is a pain in the butt. It really is. If you got 3 guys working in these things, they're screaming at each other just to be heard across the room. So they still need, there are still some drawbacks with PPE, but in areas that are immediately hazardous to life and health, it's better than the alternative. Here's a different style of half-face respirator. This is the same thing. It just doesn't have the quick latch system. Again, 3M. Like I said, this is not a 3M sponsored video. However, they're one of the biggest manufacturers of PPE in my area, so I have a lot of their stuff. These are the filters for immediately hazardous to life and health. If you take a look at the filter difference, when you buy the 6001, this is what you get. When you buy the, which ones were these? The 6923s, you get this whole setup. This is one piece. This doesn't come apart. And if you look for it, this cartridge is rated for organic vapors. This cartridge is rated for everything here. So depending on the filters you buy, one of these filters much better than the other one. It depends on proper identification of the hazard and working within that hazard. I had a buddy of mine who asked me, he had asthma, and he asked me for a recommendation because he's an HVAC technician, and he ended up in attics and some very dusty places and it was causing his asthma to go kind of nuts. He's like, hey, what can I do about that? I was like, hey, buy one of these half-face respirators, wear that for work. It's the most comfortable thing I've found. If you have to wear a mask, it's the most comfortable thing I've found so far. If anybody knows anything more comfortable, let me know. I'm always looking. But he ended up picking up these filters, these 6923s, and he called me back about 3 months later. He's like, man, there's got to be a cheaper way to do this. And I was like, well, what are you doing? And he's like, well, I'm buying the 6923s, and they're only lasting me a day. Now, this is a $40 filter. That's a lot for a day. I was like, dude, quit using these. And I set him up with the 6001s, Nuisance Organic, with the P95 overfilter. And instead of burning $40 a day, he's now burning like $2 a day, and he can be in the attics for a while, and it doesn't bother him anymore. And I even do wear these when I do attic work in the lab, things like that. When I have to go up there and move cabling around or repair a hole in a roof, which happened recently, I do that too. So that gets into point number 2 of PPE. Find PPE that is effective, but is also comfortable. The more comfortable the PPE is, the better. It's not perfect. You are breathing through a filter. It beats dying. But the more comfortable the PPE is, the more likely someone is to actually use it. So when I started, I was using these things. I was doing everything in these things. Now, this was long time ago, because I don't do that anymore. And like I said about ratings, like there's the ratings on safety glasses. So like these are proper safety glasses. I don't know if it's going to show up on these, but the ratings are right here on the lens for impact. But I have switched over to these. They're much more streamlined. They're comfortable. I can wear these all day, and I can forget I'm wearing these, and I've got something over my eyes. So much definitely make the PPE as comfortable as you can, especially if you're going to be in it for hours at a time. It is so worth it to just spend a little bit extra money and get some good but effective PPE. Fume extraction in the lab, since I do not wear a half-face respirator when I'm soldering, but fume extraction is important. If we look under the bench, this is the Hakko fume extractor. I will pop the cover off, and I'll show you guys the filter that's in there here in a minute. Now, to put this into perspective, this is a good portable air filter. So if I put my hand over it, it can cover up completely. This is the filter in my fume extractor for my soldering iron. This thing is huge. This is the pre-filter that sits on top of it. This used to be white. So, like, white. Fiberglass white. It started to yellow with the flux that it's picked up. So this, because you can see the airflow is down, pulls air through the top, pulls it through, and ejects it back out into the room. This is the filter that I use, or most of this is HEPA filter. This filter on top keeps the HEPA from getting loaded from the big stuff. So you're supposed to change 5 of these pre-filters before you have to change the big guy. When I do change the big guy, I'm going to upgrade, because this is the original just HEPA filter, high efficiency particulate air filter, I think is what HEPA stands for. This is the filter that does the small stuff. So you get 10 of those to one of these. The price difference is huge too. These are like $1 a piece. These are like $100. So I'm glad I get a long life out of these. I've had this probably 2-ish years, and I haven't had to change any of the filters yet. It hasn't even asked for a pre-filter. There's a flow meter on it that when the flow meter detects a reduction in flow, it says, hey, time to change the pre-filter. And then it'll also say when it's time to change the big filter. Now, this moves a ton of air. Like, it really does. The inlet to this thing is up here on the bench, front and center, and there's a lock line tube that comes off of this and then moves down to where I'm soldering to pull the fumes off the board and into the fume extractor. The units are not cheap. I very much am glad I have it, because this stuff is not in my lungs. Okay, story time. So, 2 quick stories, because I have talked a significant amount about safety equipment, and I did not mean to speak this long about all of this, but this is an important topic, so I wanted to do it justice. Literally to the point where this is the second time I've recorded this video, because it's that important, and I wanted to make sure this information was out there. There's more than this, but these are 2 of the biggest instances of when a supervisor told me I had the potential to die on the job and was not exaggerating in the least. One of them was we were servicing some underground data cabling, and for those who have never had to go down a manhole cover before, there's not a lot of good ventilation in there, and the areas are in tight spaces. So we pull the manhole cover off, and we have to wait for one of the safety inspectors to come in and look at the and do an air test. So he brings a meter in, and he winds this thing down the hole. It's a probe about yay big on a really long cable, just a little steel thing about probably about the size of a screwdriver handle, how wide it is. It just rolls down the hole on like a 50-foot cable, and was not a 50-foot hole. This was very shallow, but meter beeps a few times. He looks at it, and he basically says, "Hey, you're not going to die. Go ahead and enter the hole." And I was curious, so I asked him. I said, "Hey, what are you checking for?" It was a little weird. I've never had to do this before. And he said, "Oh." He was checking just in case a animal had crawled in the hole and died, because the decomposing corpse of a raccoon or a possum or something like that that's in there can release toxic gases to people. Turns out very, very toxic gases, instantly fatal toxic gases, to the point where if you had crawled down the hole and these gases were present, they couldn't even pull you out fast enough. You would pass out and you'd be dead before you hit the ground. So even if you had a winch line hooked up to your harness, and if they saw you fall, somebody tried to pull you out, you were already gone before they got you back up to the surface. So we always checked the air before we went in, just to make sure that wasn't going to happen. And that was because the spaces were sealed most of the time. They had a cover on them and things like that. The other time was when I was servicing film projectors. I had to change one of these. This was a picture I grabbed off the internet real quick. For those that haven't seen one of these before, this is a 7,000 watt xenon short arc lamp. To give you an idea how serious this is the electrical cable for the lamp. This braided steel cable is the wire. And that's it's about a 1/4 inch thick. The other electrical node is actually over here. It's a pin. It's actually a steel rod that clamps into a fixture. So what this is for is this generates the light in my case, what was a 70 millimeter movie projector for a 4D theater. This bulb, which is essentially a light bulb, can ruin your day in many ways. When they got old and unhappy, they ran about 48 volts DC at about 180 amps. That is an accurate one, 180 amps. The rectifier diodes are about that big around. Like, they're huge. And there's 4 of those. So, you adjusted the running voltage of the bulb with a rheostat that was about the size of a 4 trash cans stacked on top of each other. Big trash. About the size of a big curbside trash can is about how big this rectifier was. And that was just the rectifier and the rheostat to control the power. When they were unhappy, they spiked to about 200 amps and blew up. If you did not let the bulb cool down for 10 minutes after you turned it off, you would get third-degree burns handling it, and it might shatter because of the glass problem. If you, obviously it's 48 volts DC at 180 amps, and the rectifier was capable of probably 300. So people weld with less than that. That is a serious amount of current going through one of these things. If you struck the bulb and you looked at it without welding glasses or with the proper eye protection, you would very easily go blind. And so it could blow up. You could go blind. You get electrocuted. You get third-degree burns. As I'm telling this, I'm realizing these things actually kind of suck. But it is what it is. And we would have to change these about once a month. Because with the way these ran, you struck them in the morning, and they ran all day. They ran 12, 18 hours a day, and they got shut down at night. They'd start a fire if the dowser didn't close. Like, it's 7,000 watts. It's a lot of light. But what ended up happening was my supervisor at the time was showing me how to change one of these because it was the first one I'd ever done. And I'm a junior technician at this point, and I'm thinking I'm like, okay, this is kind of, this is a light bulb. Like, why am I worried about this? This is a light bulb. So I asked him, I said, hey, what happens if we drop the light bulb? And he looked at me point blank and said, we die. If this thing hits the ground and decides to shatter, the best thing I can equate it to that people might be familiar with is a hand grenade. The glass envelope of this particular lamp is pressurized to 26,000 psi. At least that's what I've been told. So it's got 26,000 pounds of xenon gas in it, and they blow up. I mean, I've seen these go off. I've seen them pop, and I've seen the damage that one does when it blows up under power in the lamp house. It almost punches through. It almost punches glass through a steel plate. So, with no PPE, which the PPE for this thing would essentially be a bomb suit, it's fatal, and it's quartz glass. So, the crappy thing about quartz glass is if it does end up entering the body, they can't find it on an X-ray because it's quartz. It doesn't show up, so they can't get it all. So it's not a good day. So that's the other time where that was one of the more than a few times where my boss kind of looked at me and is like, "Oh yeah, we screw this up, we die." Fortunately, everybody knew how to handle these things properly. Everything knew how to handle these things safely, and we never had an incident. And one of these never got exploded unless we were disposing of it. So nobody got hurt, and all the procedures and everything were followed as they were expected to be, and everything was good. Thanks for stopping by the lab today and taking a look at a not fun but necessary topic when it comes to lab safety and some of the hazards that we run into in the lab and how to identify them. If there is If people would like more information on topics like this, let me know. I do not mind doing the videos. I'd love to get this information out there for everybody, because you can't protect yourself from a hazard that you don't even know is there. So if there's any questions, I'll see everybody in the comments. And as always, I will see everyone in the next video. More is always on the way.